Okay, after several videos on resonance, we're now going to move into a new topic, and that is induction. Let's see an example for induction. So, if we have acetic acid, as we will show in all these videos, we're going to react our acids with water. Though I admit water is not much of a base, we will form a new conjugate base. Plus H3O plus. Great. So that's our balanced acid-base equation. Now, what happens if we change the structure and we put one chlorine atom on our acetic acid? Now we have chloroacetic acid. We won't show the mechanism. Maybe we will. Show the mechanism, break that OH bond, goes on the oxygen. Oops. Now we're going to form our conjugate base, H3O plus. Perfect. Here are two balanced equations. Now, as it turns out, the pKa of acetic acid, I think I said it's 5 in another video. If you want to be more precise, it's 4.75. As it turns out, if you replace one hydrogen with chlorine, what happens is the pKa drops by quite a bit. It goes to 2.87. That's almost 100 times more acidic. So whatever our argument is for why the pKa has changed from 4.75 to 2.87, it must involve our chlorine. What is this chlorine doing to make this anion somehow more acidic? Remember, again, we always go back to the charged species to try to explain our changes in acidity. So for some reason, this anion is more stable, meaning it's less reactive. It is less reactive how? Less basic. And therefore, this acid is more acidic. More acidic than what? Well, more acidic than what we're comparing it to, which is our regular unsubstituted acetic acid. So why would this be more stable? It must involve this chlorine. As it turns out, what people say is chlorine is more electronegative than chlorine, and therefore you build up you have a polarized sigma bond here. And this polarization puts more electron density on chlorine and less electron density on carbon. So this carbon bears a partial positive charge, and that partial positive charge stabilizes the presence of this negative charge next door. So that's a stabilizing effect, makes it more stable, less basic, therefore this is more acidic. So induction is about stabilization of charge by sigma bond polarization. We didn't move any pi bonds in this. This is not resonance. You might say, oh, but look, it's the electronegativity of the chlorine that gave rise to our inductive effect. It is the electronegativity of the chlorine, but the chlorine is not the atom that bears the charge. So this is not an electronegativity of the atom that bears the charge. It's an electronegativity that gives rise to sigma bond polarization. So this is the inductive effect or induction, and we'll see this quite a bit in acid-base reactions as well as general reactivity in organic chemistry.